All right, folks, get ready. Because today we're taking a deep dive into metaphysics. And more specifically, we're going to be tackling the concept of causation.
Oh, causation.
Yeah, it might seem like a pretty straightforward idea at first glance. One thing causes another.
Right.
But we're going to be using the Stanford Encyclopedia of Philosophy's entry on the metaphysics of causation.
Very good source.
Very, very good source. And we're going to see that it can actually get surprisingly complex and really kind of mind-bending.
Oh, absolutely.
Yeah. So before we get into the nitty-gritty, can you maybe just give us a quick explanation of what metaphysics is, for those who might not be familiar?
So imagine you're trying to understand not just how a car works, but like the very essence of carness.
Okay.
So that's what metaphysics is all about, exploring those fundamental questions about the nature of reality, like what is it behind everything we experience?
Right. So we're going kind of beyond just observing cause and effect in the world.
Yeah.
We're really trying to figure out what causation is, like at its core, right?
Exactly, yeah. And this deep dive is going to take us on a journey through different types of causation, and we're going to challenge our intuitions with some tricky scenarios, and ultimately we're probably going to be left with more questions than answers, which is always fun.
I love that. I love that. All right. So where do we even begin with all of this?
Well, the article starts by pointing out that there isn't just one type of causation. There are actually 4 distinct flavors of causation.
Okay. 4 flavors. All right. I'm intrigued. I'm ready.
So the first 2 are pretty intuitive. We have token causation, which focuses on specific events like the recent hurricane caused widespread flooding.
Okay, so like a specific instance of cause and effect.
Yeah, exactly. And then there's type causation, which deals with those general relationships we observe, like smoking causes cancer.
All right, so more like the broad patterns that we see.
Exactly. But then things get a little more interesting when we start talking about influence.
Mm-hmm.
So we have token influence, which is how specific variables affect each other. Like the amount of sunlight this plant gets influences its growth.
Okay.
And then there's type influence, which generalizes these relationships, like exercise influences your overall health.
Got it. So instead of just saying one thing caused another, we're talking about how much one thing influences another.
Precisely. And this framework helps us make finer distinctions than we do in everyday conversation. It's kind of like a scientist classifying different species.
Okay, that's a really helpful way to think about it.
Yeah.
So we're already starting to kind of rethink the way we talk about cause and effect.
Yeah,
But the article then throws us another challenge.
it does.
It starts questioning what kinds of things can even be causes and effects in the first place.
Ah, yes, the reloada problem.
Yeah. So we often think of causes and effects as those straightforward events, like a ball breaking a window. But the article suggests that things like facts
Mm.
and even variable values can play these roles. Now, I kind of get how facts could be causes and effects, but how can a value be a cause or an effect?
So think about baking a cake.
Okay.
The amount of sugar you use, which is a variable value,
Mm-hmm.
can determine whether your cake is overly sweet or just right.
Oh, okay.
So that specific value, has a direct impact, a causal impact on the outcome.
Right, right. So the specific value is like a part of the causal story.
Yeah, exactly.
Okay. But then the article throws in, I don't know, a real head scratcher for me. It talks about a spinning ball heating up.
Okay.
And it asks whether those are one event or 2 separate events.
Mm-hmm.
And I'm thinking, like, isn't it obvious that it's just one thing happening? It's a spinning ball heating up?
Well, the spinning and the heating, they occur at the same time, right?
Hmm.
And in the same place. But their causes and effects can be distinct. For example, friction from the surface might cause the ball to heat up, but it's your initial push that causes the spinning.
So even though they happened at the same time, in the same place, they have different causal stories.
Exactly.
That's pretty counterintuitive.
It is, yeah. And to account for these nuances, some philosophers propose that we need a more fine-grained way of looking at these events, where we consider not just the time and place, but also these specific properties and objects involved.
So really breaking it down to kind of the finest level of detail?
Exactly. And then, just when you think you're starting to get a grasp on things, they throw yet another curveball. The idea of absences as causes.
Absences, like something not happening, can be a cause?
Yes. So if someone forgets to water a plant, leading to its death, can we say that the lack of watering caused the plant to die?
It's not like an event that caused the death. It's the absence of an event.
Exactly. And this is where this concept of facts as causes and effects comes into play.
Okay.
The fact that the plant wasn't watered can be considered a cause of its death, even though there wasn't a specific not watering event.
Oh, wow. Okay. So we've got events, facts, and variable values all kind of vying for a spot in the causal arena. It's getting crowded in there.
It really is. And just when you think you've got a handle on all that, they introduce us to a whole new set of challenges. These preemption scenarios where a backup cause is like lurking in the wings, ready to step in.
Preemption. So like a philosophical understudy waiting to take the stage.
You could say that. Imagine Billy and Susie both want to break a window.
Yeah, I'm picturing it.
Billy throws a rock, shattering the glass. Susie was about to throw hers too, but Billy beat her to it.
Gotcha.
Billy's action preempted Susie's, making him the sole cause, even though Susie could have caused the same outcome.
So it's not enough for a cause to be, like, capable of producing an effect. It also has to be the one that actually did it, in that particular instance.
Precisely. And this is really just the tip of the preemption iceberg. We've got even more mind-boggling scenarios coming up, like late preemption and double prevention. We'll get to all that.
Okay, late preemption, double prevention. All right, I'm going to need a bigger whiteboard for this one.
Yes, you will.
All right, so we're going to dive into those even more complex preemption scenarios when we come back.
These preemption cases are really fascinating, They really make you think about what actually makes a difference in the world.
Yeah, it's like if Susie had just been a fraction of a second slower with that rock, would we even be talking about Billy as the cause? It makes you wonder if causation is more about timing than anything else.
It's a great point, yeah. And those tiny shifts in timing, they can lead to some really wild scenarios. Like, remember that late preemption example with Patricia, who was terminally ill?
Right.
Let's say she was going to die from her illness on Tuesday, but she actually ended up dying from a morphine overdose on Monday.
Right, so her illness was still kind of a cause, like in the background.
Exactly, yeah. Even though the overdose was the immediate cause, the thing that actually triggered the death, her illness was still there, lurking, like a looming threat. It's a good reminder that causes can kind of hasten or delay effects, and sometimes those distinctions aren't so clear.
It's like it adds this whole other layer of like time and sequence to causation that we don't always think about.
It does, yeah. And then you mentioned double prevention, which is even more kind of twisty-turny.
Yeah, tell me about that one.
Okay, so picture James Bond, our favorite secret agent.
All right, on there.
Classic Bond scenario. He swoops in, shoots down a missile that's headed straight for Blofeld's evil lair.
Okay, so far so good.
So he prevents Blofeld's death, right?
Right.
But here's the twist. Let's say that unbeknownst to Bond, if that missile had hit Blofeld's compound, it would have also taken out a hidden server that was about to launch a massive cyber attack.
So Bond, by saving Blofeld, actually caused this cyber attack to happen.
Exactly. It's like a chain reaction, a causal domino effect where preventing one thing leads to another completely unintended consequence.
I like those butterfly effect scenarios, where one tiny action can have huge ripple effects.
It is, yeah. And just when you think you've got a handle on double prevention, the article throws preemptive prevention into the mix.
Okay, hold on. Preemptive prevention. This is getting a bit much.
It is a bit of a mouthful. So picture the same Bond scenario, right? Missile headed for Blofeld. But this time, Blofeld's compound has some super high-tech defense system.
Okay, so even if Bond hadn't stepped in, the missile wouldn't have hit its target anyway.
Exactly, yeah. Bond's actions, they were heroic and all, but they were ultimately unnecessary. He prevented something that was already being prevented.
It's like trying to turn off a light switch that's already off.
It is, yeah. So did Bond really cause anything, or was he just, kind of going through the motions? It's a philosophical brain teaser.
That is a good one. It seems like context is so important here. It's not just about what did happen.
Right.
It's also about, like, what would have happened if things had played out differently.
Exactly. Those counterfactuals, they really matter.
Okay. Well, so far, we've talked about these specific instances of preemption, but how does all of this relate to the broader distinction between token and type causation?
Good question, yeah. So remember, token causation is about those specific instances, like this particular drought caused this particular famine, while type causation is about those general relationships, like droughts cause famines.
Right, got it. So one is about like a single event, and the other is about like the kind of overall pattern.
Exactly, yeah. And there are a couple of main views on how these two relate to each other. One view is that type causal claims are just like summaries of lots of individual token events,
Okay.
like saying, smoking causes cancer because we've seen tons of cases where individual smokers developed cancer.
So it's like building a case based on like the weight of the evidence, right?
Exactly, yeah. But then there's another view that sees type causation as something more fundamental, more basic. It
Right.
says that Chris's smoking caused his cancer because smoking in general causes cancer.
So it's not just about the individual cases, but about a deeper connection between smoking and cancer
Yeah.
as like categories.
Exactly, yeah. And of course, there are some tricky examples that challenge both of these views. The article talks about a golfer who hits a ball, it bounces off a tree, and lands right in the hole for a hole-in-one.
Oh, talk about a lucky shot.
Right. So, in that specific case, hitting the tree caused the hole-in-one. That's token causation, no doubt about it. But would we say that, in general, hitting a tree causes holes-in-one?
Probably not, right? I mean, that doesn't seem like a reliable strategy.
It doesn't know. So we can have token causation without necessarily having type causation, but what about the other way around? Can you have type causation without any actual token instances to back it up?
Hmm, that's an interesting question.
It is, yeah. And the article gives a pretty dark example to illustrate this. It says drinking a quart of plutonium causes death. Now, chances are no one's actually ever done that, right?
Thankfully not.
So there are no token instances of this causing death. But we'd still say that it's true, right? Drinking a quart of plutonium would cause death.
Yeah, I think we can safely assume that.
We can, yeah. So this suggests that type causation can exist even without any specific instances to point to. And this raises all sorts of questions about how we establish those causal links when we can't rely on direct observation.
Yeah, it makes you wonder how we even figure this stuff out.
It does, yeah. And to answer that question, we need to dive into the world of causal models. These are like the tools that we use to represent and analyze these complex relationships.
Causal models. Are those like the diagrams philosophers draw on those big chalkboards?
They can be represented visually, yeah, but they're much more than just diagrams. They're really a way of thinking about how different variables influence each other. And they come in a couple of flavors,
Yeah.
deterministic and probabilistic.
Deterministic and probabilistic. Okay, those sound a little technical.
They do, but they're actually pretty easy to grasp. Deterministic models, think of them like a really precise recipe. If you follow the steps exactly, you'll always get the same result.
So, like a formula for causation.
Exactly, yeah. They use equations to spell out exactly how the value of one variable depends on the values of others. Like, remember that example of the neuron firing patterns we talked about earlier?
Right.
That was a deterministic model. Each step in the process was determined by the step before it.
It was like a chain reaction, yeah.
It was, yeah. But then you have probabilistic models, which allow for a bit more wiggle room.
Okay, so those are a bit more flexible, a bit less rigid.
They are, yeah. They recognize that causal relationships aren't always black and white. They use probabilities to express the likelihood of different outcomes.
So more like a weather forecast than a recipe.
Exactly, yeah. We might say that there's a high chance of rain given certain conditions, but it's not guaranteed.
So probabilistic models allow for that element of like randomness or uncertainty that we often see in the world.
They do, yeah.
This is amazing.
Mm-hmm.
We're really starting to see how much complexity is packed into this idea of causation. It's like we started with what seemed like a simple concept, and now we're discovering this whole universe of types, counterfactuals, models.
Yeah, that's a lot to take in.
It is, yeah.
Yeah.
But now that we have a better grasp of these causal models, I'm wondering, like, what makes them accurate? How do we know they're actually reflecting reality?
That's the million-dollar question, isn't it? And that's exactly what we're going to tackle when we come back.
Okay, so we've covered a lot of ground already. We talked about different types of causation. We wrestled with those preemption scenarios. And now we're diving into the world of causal models and this question of accuracy.
Right, right. Because it's one thing to build a model,
Yeah,
but it's another to make sure it's actually, telling us something true about the world.
exactly. So it's not enough for a model to just look good on paper.
Right.
It has to actually capture something real about how cause and effect work out there in reality.
Right. Exactly. And one of the key ideas here is that a model's accuracy has a lot to do with its ability to predict counterfactual.
Counterfactuals. Okay, remind me what those are again.
It's basically those what-if situations
Okay.
where we imagine, changing something and seeing what would have happened.
So, like, if our model can tell us what would have happened if we tweaked a certain variable,
Hmm.
and if that prediction lines up with, how we think things actually work,
Hmm.
then that's a good sign.
That's a good sign, yeah. And the article talks about different types of counterfactuals,
Okay.
like interventionist counterfactuals,
Yeah.
where we imagine actually like directly manipulating a variable to see what effect it has.
It's like running a thought experiment.
Yeah.
It's kind of playing around with the variables in the model and seeing if it spits out results that make sense.
Exactly, yeah. But even within this counterfactual approach, there are different levels of, how strict we want to be.
Okay.
Some philosophers say a model should get all the counterfactuals right, while others are a bit more lenient. They focus on a smaller set of kind of plausible scenarios.
Right, right. Because, we can't expect a model to account for every crazy what-if scenario we can dream up. Like,
Exactly.
what if gravity suddenly reversed itself?
Oh,
Or
right.
what if, the sun exploded tomorrow?
Yeah.
At some point, we have to kind of focus on those counterfactuals that are actually relevant to the specific causal relationships we're interested in.
Exactly, yeah. We have to be kind of strategic about it. And the article also highlights another interesting perspective on accuracy.
Yeah.
This is the idea that a really good model, a truly accurate model, needs to go beyond just counterfactuals.
Okay.
It needs to actually capture the underlying processes that connect causes and effects.
Oh, like those connecting processes we talked about
yeah,
earlier.
exactly.
Kind of the bridge between cause and effect. So it's not enough to just say, if A happens, then B is likely to happen.
Right.
We also need to show, how A leads to B, the actual mechanism involved.
Yeah.
Precisely. Yeah. It's like the difference between knowing that pressing the gas pedal makes the car go faster
Okay.
versus understanding, the whole chain of events that actually make that happen, the combustion, the transmission, all that stuff.
Right, right. It's like we need to see the gears turning, like the inner workings of the causal machine.
Exactly. And this idea of connecting processes, it adds this whole other layer of complexity to the question of accuracy.
Right, because now we're not just judging whether a model gets the right inputs and outputs.
Right.
We're also looking at whether it captures the kind of the essence of the causal relationship itself.
Exactly. Yeah. It's a much richer, more nuanced way of thinking about it.
It is, yeah. And I have to say, it's been amazing to explore all of this with you today.
It's been fun.
We started with what seemed like a simple idea, this concept of causation.
Mm-hmm.
But we've ended up in this incredible labyrinth of types, counterfactuals, connecting processes, all these amazing ideas.
It's quite a journey.
It really is. Yeah. It's mind-boggling, but also so fascinating.
Absolutely. And, even after all this, we've really only scratched the surface.
Right.
There's so much more to explore, so many more debates and questions and mysteries.
It's like we've opened this door into this hidden world where causes and effects are interacting in all these complex ways, sometimes predictable, sometimes totally chaotic.
It's a strange world.
It is, yeah. But it's a world that, that invites us to keep asking questions, keep exploring, keep trying to understand.
Absolutely. And for anyone who's, eager to delve even deeper into all of this, I highly recommend checking out the full Stanford Encyclopedia of Philosophy entry.
Yeah, great source.
Lots of great food for thought in there.
Absolutely. And as we wrap up this deep dive, I want to leave our listeners with a final thought to ponder. Think about the last time you used a tool, maybe a hammer to drive in a nail or a whisk to beat egg whites.
Okay.
Did you cause that outcome? Or was it the tool? Where does the connecting process actually lie?
Yeah. That's a good one. Something to think about.
Yeah, it really makes you think about the role of, agency and intention and all of that in causation.
It does, yeah.
So thanks for joining us on this journey into the heart of causation.
My pleasure.
Keep those brains buzzing, and we'll catch you next time.